Dear students, under the topic Integral Calculus, we are going to learn a series of lectures on definite integrals. In this video lecture, we will learn the definition of definite integrals and some properties under definite integrals. Now the definition goes like this. If integral f of x dx is equal to capital F of x plus c, then integral over a to b f of x dx is equal to f of x plus c between the limits a and b. So on substituting the upper limit minus the lower limit, we get f of b minus f of a. Now, we are given an integral f of x dx, which on integration leads us to capital F of x plus c. Now, when we take limits for this integral, the lower limit being a and the upper limit taken as b, on integration, it gives us f of b minus f of a. This is because we have to apply the upper limit first minus the lower limit in this result. That is, this will be actually equal to, on applying the upper limit, it will be f of b plus c and minus the lower limit. So, on applying the lower limit, it will be f of a and minus c. So, this plus c and minus c gets cancelled and hence we get f of b minus f of a. So remember, the constant of integration will not be added in definite integrals. So here itself, in fact, you can eliminate it. So integral a to b f of x dx is equal to f of b minus f of a is known as the definite integrals. So now using this concept, we are going to learn some properties of definite integrals. The first property being integral a to b f of x dx is equal to minus integral b to a f of x dx. That is, when the limits are interchanged, that is the upper limit becomes the lower limit and the lower limit becomes the upper limit, a negative sign is multiplied with the integral. So remember, integral a to b f of x dx will be equal to minus integral b to a f of x dx. So when we flip the limits, the integral will be multiplied with a negative sign. Now let us prove this result. Now in order to prove this property, first we shall consider the left hand side. So the left hand side is given as, so if you see, the left hand side is integral a to b f of x dx. Now as per the definition of definite integrals, this will be equal to f of x between the limits a to b. And on applying the limits, we get, when we apply the upper limit, we get f of b minus the lower limit, so f of a. So this is the left hand side that we have obtained. Now we have to prove that the right hand side is also the same, for which we will consider the right hand side that we have in this property. So what is the right hand side? Minus integral a to b, b to a, minus integral b to a f of x dx is the right hand side given in the property. So on applying the definition of definite integrals, this will be further equal to, so this minus sign comes as it is, and the integral b to a f of x dx on integration will give us f of, now if you see, the integral of f of x is capital F of x between the limits b to a. So that will be minus of, so now if you see, the upper limit is a over here, so it will be f of a minus the lower limit. What is the lower limit? It is b. So on applying b, we get minus f of b. Now we have a negative sign inside. So on multiplying this negative inside the bracket, we get minus f of a, and minus into minus becomes f of b. So plus f of b. So this can be rewritten as f of b minus f of a. And so this gives us the right hand side. Now, what was the left hand side that we obtained? It is f of b minus f of a. And what was the right hand side? F of b minus f of a. So both are same. Therefore, the left hand side is equal to the right hand side. Hence, we have proved the given property. That is, integral a to b f of x dx is equal to minus integral b to a f of x dx. So hence we have proved the first property. Now we shall prove the second property. The property 2 says that integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where c is some value of x between a and b. So what does this property say? Now if we consider the values between the interval a and b. So a, after that we will have numerous values, and at some point c is some value of x between a and b. So somewhere we have a c, and after that the value b comes. So c is a value between a and b. So in the interval a comma b, c is some value in between a and b. Now if we have so, the interval, that is integral a to b, can be splitted up as integral a to c plus the integral c to b. So that is what the property says. So the integral a to b can be splitted up as the integral a to c plus the integral c to b. So let us prove this, for which first we shall consider the left hand side. So what is the left hand side? The left hand side is given by integral a to b f of x dx. So integral a to b f of x dx. And this we know that on integration it will be f of x between the limits a to b. And on applying the limits we get the upper limit is b. So f of b minus the lower limit. So f of a. So this is the left hand side that we have. Now we have to take the right hand side and we have to prove it is also equal to f of b minus f of a. So let us do that. So what is the right hand side? Integral a to c f of x dx plus integral c to b f of x dx. So let us take and write this. So we have taken and we have written the right hand side. And so this will be equal to, now what about the first integral? On integration, f of x will become capital F of x. Between the limits, now here what is the lower limit? It is a. And here what is the upper limit? C. So that we have to write. Plus, now this integral on integration gives us f of x. And here what is the lower limit? It is c. And the upper limit is b. So the after integration we get this. So that will be further equal to, now in this we have to apply the upper limit minus the lower limit. The upper limit is c, and so we will be getting f of c minus the lower limit is minus f of a plus, now in a similar manner here also we have to apply the limits. The upper limit is b, so f of b minus the lower limit, which is f of c. And now if you observe, we have plus f of c minus f of c over here, which can be cancelled. So after cancelling, we get this minus f of a plus f of b. Now this can be rewritten. We will write f of b first. So f of b minus this term, that is f of a. So this is the right hand side. So we observe that the left hand side is f of b minus f of a, and the right hand side is also f of b minus f of a. Therefore, the left hand side is equal to the right hand side. Hence, we have proved the property that integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, since we obtained both to be same on finding them separately. We got f of b minus f of a. Hence, we have proved this. So next we shall prove property 3. Now here we have property 3, which says that integral minus a to a f of x dx is equal to twice integral 0 to a f of x dx. Now if we take integral minus a to a, it will be equal to twice integral taking it as 0 to a f of x dx. But when? Only if f of x is an even function. So this is very important. When the taken function f of x is an even function, then integral minus a to a f of x dx can be written as twice integral 0 to a f of x dx. We shall see the proof of this property now, for which first we should know what is an even function. The function f of x is said to be an even function if f of x is equal to f of minus x. That is, in the function f, if we replace the value of x by minus x, we will again get f of x only. So they both will be same. So this such a function is known as even function. Now, having this in mind, we shall prove the required property. We will consider the left hand side. So, what is the left hand side? Integral minus a to a f of x dx. So, we will take it. So, integral minus a to plus a f of x dx. Now, this integral has to be splitted up by using property 2. So, how are we going to split this integral? Now, we know that minus a is a negative value and plus a is a positive value. So, in between there will be 0 between these two values, because all these values will be negative values, and after 0 the remaining values will be positive values. So, now the interval minus a to plus a can be splitted up as minus a to 0 and 0 to a. So this integral can be written as minus a to 0 plus 0 to a. And how can we write that? By using property 2 which we have learnt. That is, property 2 says that if we have integral a to b and c is any value between a and b, then we can split up the integral as a to c plus c to b. Now what is the value of c over here? It is 0. So 0 lies between minus a and plus a, and so this integral can be splitted up and it can be written as integral minus a to 0 f of x dx. So this is the first split up. The second split up is from 0 to a. So plus integral 0 to a f of x dx. So first we have to split up the integral and we have to write it. So this was done using property 2. So property 2. Now after this, let us mark this as equation 1. So after marking this, now we will consider the first integral and evaluate it separately. That is, I am going to consider integral minus a to 0 f of x dx, and I am going to evaluate this integral separately. Now since f of x is an even function, this f of x is equal to f of minus x also. So instead of f of x, I can replace it as f of minus x, since the given function f is an even function. So this will be equal to integral minus a to 0. Now f of x can be replaced as f of minus x dx. The reason being, since f of x is an even function. Now I am going to make substitution for this integral, that is, I am going to substitute. So put this minus x I am going to take as y. So put y is equal to minus x. So from this, what will be dy? It will be equal to minus dx. And I can rewrite this as dx is equal to minus dy. So I substituted y to be equal to minus x and I have obtained dx to be equal to minus dy. We should always remember, whenever we make a substitution, we should take care of the limits also. That is, we have to change the limits. So when, now here what is the lower limit? Minus a. That means x is equal to minus a. What is the limit for y? We have to check. So when x is minus a, if we put minus a at the place of x, we get minus into minus plus and we get a. So y will be equal to a. So this is the lower limit. So when x is equal to minus a, it has changed to y equal to a on substitution. Then the upper limit we have to check. Here what is the upper limit? X is equal to 0. So when x is equal to 0, what about y? So if you put x as 0 over here, the value of y is also 0 only. So the upper limit remains 0 itself. So Now the limits has changed as instead of minus a, the limit will be plus a, and at the place of 0 it has remained as 0 itself. Now we will substitute all this in this integral. So therefore, first we will write this, that is integral minus a to 0 f of x dx is equal to, now what has happened, the lower limit has been changed to a. So integral a to, the upper limit is 0 itself, a to 0. So these are the limits. Then f of, instead of minus x we have to write it as y. So f of y. Now instead of dx we have to write minus dy. So we will be having minus dy. So therefore this integral, that is integral minus a to 0 f of x dx, has been changed as, this minus we can take out. So minus integral a to 0 f of y dy. Now by using property 1, we know that if we have integral a to b f of x dx, if the limits are flipped, then the integral becomes minus integral b to a f of x dx. So the integral is multiplied with a negative sign. Now I am going to flip the limits over here. So integral a to 0 I am going to write as integral 0 to a. So we have to multiply this integral with a negative sign. But already we have a negative sign here. So minus into minus will become plus. And so I will be having integral 0 to a f of y dy. Now we have obtained integral minus a to 0 f of x dx as integral 0 to a f of y dy. In indefinite integrals, one variable can be changed as another variable with the same properties. So forget about all these substitutions. In general, in definite integrals, this integral can also be written as 0 to a. Instead of y, we can write as f of x dx, because I didn't change anything in the variables. That is, just y has been replaced as x and dy has been replaced as dx. So there is no comparison with this substitution. So that is over actually. In definite integral, if you have a variable, it can also be changed as another variable but with the same properties. There should be no change of sign or anything. So we're using that concept. I have just changed this integral as integral 0 to a f of x dx. Now integral minus a to 0 f of x dx is equal to integral 0 to a f of x dx. This we can take and substitute over here, because this was the integral that we had taken separately and we have evaluated it. Now we will take and substitute this in equation 1. Therefore what we obtain is, so on substituting the first integral, it has been changed like this. That is, in equation 1, integral minus a to 0 f of x dx, which has been evaluated as integral 0 to a f of x dx, is substituted. So on after substitution, we get this. Now both the integrals are same, and so therefore we can just add it and we will be getting twice integral 0 to a f of x dx. Therefore we have obtained integral minus a to a f of x dx to be equal to twice integral 0 to a f of x dx, which is the required property that we have to prove. So property 3 we have proved. So I hope you would have understood this property. So hence it is proved. Next we will move on to property 4. Property 4 says that integral minus a to a f of x dx is equal to 0 if f of x is an odd function. So remember, if f of x is an odd function, then integral over minus a to plus a f of x dx will be equal to 0. So what is an odd function? So in order to prove this property, first we should know what is an odd function. So the function f of x is said to be an odd function if f of x is equal to minus of f of minus x. That means if the variable x is changed as minus x in the function f, then we will have the function f of minus x multiplied with negative sign, and that will be equal to f of x. You will understand this better when we do problems on definite integrals. As of now, you remember that f of x is equal to minus of f of minus x. We will be making use of this in order to prove this property. Now, in order to prove this property, as we did while proving property 3, in the same way, we will be splitting up this integral minus a to plus a as minus a to 0 and 0 to a by using property 2. So, I have explained this while proving property 3. So, kindly go through it once again to understand that. So, how I am splitting up this integral. So, this integral can be splitted up and written as, so here we have minus integral minus a to 0 f of x dx plus 0 to a f of x dx, and let us mark this as equation 1, and this we have splitted up by using property 2. So I hope you would have understood how we are splitting up this. Now, as we did in property 3, in a similar manner, after marking this as equation 1, we will consider the first integral separately, we will evaluate and we will substitute here. So, while considering the first integral separately, we will be having integral minus a to 0 f of x dx. Now, since f is an odd function, we know that f of x is equal to minus f of minus x. So, we will replace this f of x as minus of f of minus x. So, that will be equal to integral minus a to 0. So, minus of f of minus x dx. So, taking that minus sign outside, this will be minus integral minus a to 0 f of minus x dx. Now, we are going to make substitution over here. In the same manner as we did previously, we will substitute y to be equal to minus x. So, put y is equal to minus x. So, we get dy to be equal to minus dx, and hence we can rewrite it as dx is equal to minus dy. So, on substituting y equal to minus x, we get dx to be equal to minus dy. So, whenever we make a substitution, we should also make sure of the limits. So, when what is the lower limit? Minus a. So, x is equal to minus a. What about y? Y will be equal to, so when we substitute minus a for x over here, minus into minus will become plus. So, y will be equal to a. So, this is the upper limit. Also, we have to make sure of the, this is the lower limit. Next, we have to do for the upper limit also. So, when x is equal to, what is the upper limit? It is 0. So, when x is equal to 0, what about y? When we substitute x as 0 over here, y will also remain as 0 itself. So, the upper limit is 0 only. So, now after making the substitution, the integral changes and we will have the lower limit as a and the upper limit as 0. So, we will rewrite this. So, I will take this integral, this integral, and I will write. So, it will be, so integral minus a to 0 f of x dx is equal to, now this I have to write. So, this will be equal to, first we have a negative sign. So, minus integral. Now, we have made a substitution. So, after making substitution, what is the lower limit that we have obtained? The lower limit is a and the upper limit is 0. So, we will change this limits. So, these limits will be changed and we will get the lower limit as a and the upper limit is 0. And then we have f of minus x. What is minus x? We have substituted that as y. So, this will become f of y. So, we will have f of y multiplied with dx. So, what is dx? Dx is equal to minus dy. So, that we will write. So, we will be having this as minus dy. So, this will be equal to, now minus, this minus into minus will become plus integral a to 0 f of y. Now, this a to 0, what we will do? We will change the limits. We will flip the limits. So, we know that from property 1, whenever we flip the limits, the integral will be multiplied with a negative sign. So, minus integral 0 to a here dy. So, f of y dy. So, the integral changes as minus integral 0 to a f of y dy. Now, we shall take this and substitute in equation 1 at the place of my integral minus a to 0 f of x dx. So, on substituting, what do we get? So this is equation 1. Now in this equation 1, we are just replacing integral minus a to 0 f of x dx by minus 0 to a f of y dy. So in fact, I already told you the variable can be changed. So when we have a single variable, that is it will be changed as minus integral 0 to a f of x dx. I am not changing any other thing. Just the variable y has been changed as x and dy has been changed as dx. So we can do this in definite integrals. So on doing so, what we get is, so we get integral minus a to a f of x dx. That is the left hand side of the equation 1. And instead of this, we will replace it by minus integral 0 to a f of x dx. So that we have replaced. Plus this integral comes as it is. Integral 0 to a f of x dx. So now after this, what we have to do, we have to check here. So we see that both the integrals are same with opposite signs. Therefore we can cancel both of them, and so that will give us 0. Hence we have proved that integral minus a to plus a f of x dx is equal to 0 whenever f is an odd function. That is very important. So hence we have proved this. We shall now next prove property 5. So here we have the last property of this video lecture, which is property 5, which is also one of the very significant property that simplifies the definite integral problems, and it is applied in solving various problems. Now we shall prove this property. So the idea of the proof will be, we will consider the right hand side, we will solve it, and we will bring the left hand side from it. So that we are going to do. So first we will consider the right hand side. So what is the right hand side? It is integral 0 to a f of a minus x dx. So before that, I would just like to read out the property for you. So integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So if you see, this integral can also be written as f of function of the variable x can be replaced as the upper limit minus x. So remember, so integral 0 to a f of x dx will be equal to integral 0 to a f of upper limit is what? A. So a, it can be written as f of a minus x dx. So by doing so, the problem simplifies more easier. You will understand it while doing problems under this topic. So anyway, now let us prove this. So I have considered the right hand side, and I am going to make a substitution in the right hand side now. So the substitution is, I am going to put this a minus x as y. So put y is equal to a minus x. So from this, what will be dy? On differentiating, dy will be equal to, a is a constant, so that will become 0 after differentiation. So in a differentiation of minus x will be minus dx. So from this we get dx to be equal to minus dy. So we made a substitution of a minus x as y, and we have obtained dx to be equal to minus dy. Also, whenever we make a substitution, we must make sure of the limits also. So if you see here, the lower limit is 0, which means that x is equal to 0. So when x is 0, what about y? So we have to put 0 at over here. So if we put x as 0, we see that y is equal to a. So when x is 0, y is equal to a. And what about the upper limit? It is a. So when x is equal to a, what do we get? Y to be equal to, so if we put x as a over here, a minus a will become 0. So y will be equal to 0. So the lower limit has been changed as 0 to a. And 0 has been changed as a. And the upper limit was a, which has been changed as 0 after this substitution. Now we will make all these substitution in our integral. So this integral will be equal to integral, instead of 0, it has been changed as a. So a to upper limit is changed as 0. So this is 0. Now f of, what is a minus x? It has been substituted as y. So f of y multiplied with dx. Dx has been has become minus dy. So minus dy. So this integral will be further equal to, taking this negative sign outside, minus integral a to 0 f of y dy. And by using first property, we know that if we flip the limits, the integral can be multiplied with a negative sign. So that's equal to, already we have a minus here. So when this integral is multiplied with a negative sign, it becomes positive. And so we will be getting integral 0 to a f of y dy. So remember, I have flipped the limits here. That is, the lower limit has become the upper limit and the upper limit has become the lower limit. Because of this, because of which the minus has got vanished. By using property 1, you can refer it. Further, I have also told you that in definite integrals, a variable can be changed to another variable as it is without any change of other properties. So this can be written as integral 0 to a f of x dx. Now, what is this actually? It is our left hand side. So the left hand side is 0 to a f of x dx. So we started with our right hand side. We made the substitutions, and after making the substitutions, we see that we have arrived at the left hand side. So hence we have proved this property. So hence proved. So I hope you would have understood all the 5 properties. In our next video, we will solve problems under this topic, definite integrals. So kindly follow the next video lectures. Thank you.